Okay, so now we're going to talk about another greedy algorithm called Dijkstra's algorithm. So Dijkstra's algorithm attempts to solve a problem known as the single source shortest path problem. Given a source vertex in a weighted connected graph, find the shortest path to all the other vertices within the graph. Now it's important to note that we are not interested in a single shortest path that covers all the vertices within the graph. No, that would be another version of the traveling salesman problem, which would be much harder to solve. What we are looking for instead is a family of shortest paths, all of which are starting from the source vertex and leading to different vertices within the graph, right? So how does Dijkstra's algorithm figure out the shortest paths to a graph's vertices be? It does this in the order of the distance of those vertices from the source path. What does that mean? It means that Dijkstra's algorithm will first figure out the shortest path to its nearest node, then to its second nearest node, then to the third, and so on and so forth, right? Which means by the time the ith iteration for Dijkstra's algorithm has commenced, the algorithm has already figured out this nearest I minus 1 vertices. So these vertices, the source node, the edge weights in the shortest path to these vertices, all of them together form a subtree Ti. Let's call that subtree Ti, right? So we have a source node S, and there are some nodes between them, and then you have a vertex V within that subtree, right? I'm not drawing the exact subtree because we don't care what lies between a given node V and the source node S. So let's call this Ti. Now this vertex V, which is a placeholder for any vertex within that subtree, right, is directly adjacent to some vertices that are not in the subtree. Let's call these vertices, let them be represented by a vertex called U, okay? So the way Dijkstra's algorithm works is by computing for each of these adjacent vertices, we can call them fringe vertices. So for each of these fringe vertices, Dijkstra's algorithm computes the sum of the distance between V, which is the nearest vertex to U in the subtree, and U. So this is given by the edge weight between V and U. And to this, we add the distance of the shortest path from source node S to the node V, right? We are going to call this as dV. The whole idea of Dijkstra's algorithm is to compute this and try to minimize this sum for each of the fringe vertices, right? Once you've computed the minimized sum of this two for each of the vertices, then you would choose the lowest among them. So that's how the Dijkstra's algorithm works. Before we start tracing, have a quick look at the pseudocode for Dijkstra's algorithm.